Hello friends, today I will discuss about differential characteristics of ABB make RET670 relay, and also how the we can see the differential current bias current in RET670 HMI. To see the current in the HMI of RET670, you have to press the measurement menu. In the measurement menu, if you press the right arrow, then you get the analog primary values. In the analog primary values, the menu TRM40, you can get the values of the primary and LV side current. Here HV side current is for channel 1, channel 2 and channel 3 for red, yellow and blue phase respectively. Channel 1 is the red phase current is 84 ampere and angle is 0 degree, and for channel 2 current is 90 ampere, that is for yellow phase current is 90 ampere and angle is 235 degree. And next we can see the current for channel 3 is blue phase current is 76 ampere and angle is 119 degree. Then we can get channel 4 is LV side red phase current, which is 142 degree and angle is 179 degree. Then we can see the channel 5, that is yellow phase current, 151 ampere and 55 degree angle. Then blue phase is for channel 6 is 120 ampere and angle is almost 300 degree. Here you can see the red, yellow and blue phase current and the angles. Now we will see the different differential current and bias current for RET 670. Here the transformer capacity is 160 MVA and HV side is 220 kV and LV side is 132 kV. Now to see the bias current and differential current, we have to go to the back to the main menu, and main menu, then we can click the test menu. In the test menu, if we press the right arrow, then we will get the different menus as shown in this figure. That is, first is ID test mode, binary input values, binary output values, function test modes, and then function status. The function status, you will get the differential protection. In the differential protection, you will get the transformer differential 3 winding current. Then you will get the T3D1. In T3D1, you will get at the last menu the value for differential and bias current. Now we will scroll down to the last menu. Here coming as STL1, STL2, then STL3, then INT fault, then you can get external fault, then come down to the BLK2H, and then come down to BLK2HL1, and then come down to BLK2HL2, and then come down to BLK2HL3, and then BLK5H. It is for fifth harmonic. BLK 5 HL1 and BLK 5 HL2. Then again scroll down, it is come as BLK WAV and then BLK WAVL1, and then again scroll down, it is unnecessary. And then it comes to as ID2HL1 and ID2HL2 and ID2HL3 as a 0 ampere. It is the differential current in per unit quantity for red, yellow and blue phase. Then again scroll down to the next value. It is come as IDL1 as for minus 2 ampere and IDL2 as 3 ampere and IDL3 is the 4 ampere. It is differential current for red, yellow, blue phase. And next come down as magnitude, that is IDL1 magnitude, IDL2 magnitude. It is the differential current magnitude, all are almost same. And then come down as the bias current is 83 ampere. it is the maximum of HV current in RET 670 bias current. The differential characteristics for RET 670 has been shown in this diagram. The characteristics for RET 670 and RET 650 is almost same. In the characteristics is shown the initial slope, initial boundary is for bias current in section 1 up to end section 1, the bias differential current must be greater than ID minimum to relate to send a trip signal. Then the second boundary, that is if the bias current is greater than end section 1 to end section 2, then the slope must be fulfill slope section 2 to relay to send a trip signal. Then beyond end section 2, a higher slope is given so that the saturation due to CT in through fault can be covered. That is to avoid any maloperation due to CT saturation in through fault condition. And again there is a high set condition which has been shown in the upper side of the diagram. If the differential current is beyond this set value, then relay will operate unconditionally. Here the differential current is the vector sum of the two current, where I1 and I2, if I1 is the primary current in per unit quantity and I2 is the secondary current in per unit quantity, I1 and I2 are the percentage of the full load current. But here bias current is the percentage of the maximum of full load current in the HV side. In RET 670 and RET 650, the bias current is same, that is it shows the maximum value of the HV side current. If red, yellow, blue phase current is respectively 85, 90 and 88 ampere, then it will take the bias current as 90 ampere. That is 90 ampere is the maximum of the HV of red, yellow, blue phase current. This is the characteristics of the RET 670. Now in the first boundary, that is for 0 less than I restrain less than end section 1, I differential greater than must be greater than ID minimum. And that is the ID minimum is the initial value of the differential current. It is given for tap mismatch. Due to tap mismatch, there exists some amount of differential current, and also due to CT mismatch, this amount of differential current exists. The second boundary is end section 1 to I restrain less than I restrain and less than end section 2. In this boundary, I differential must be greater than ID minimum plus slope section 2 into I restrain minus end section 1. In the third region, that is where I restrain is greater than end section 2, I differential must be greater than ID minimum plus slope section 2 into end section 2 minus end section 1 plus I restrain minus end section 2 into slope section 3. This is the three boundary of the RET 670 characteristics. Again there is a setting of high set. If you give the percentage impedance of the transformer, it will automatically calculate the value of the high set. This is the characteristics of the RET 670.